Before we do binomial distribution, there are some terms that you need to know. What are the terms that you need to know? Number one, random variable. Number two, Bernoulli's trial. Number three is the binomial distribution. So there are three things that you need to know. So I will go through them one by one slowly and let you know what is a random variable and what is a Bernoulli's trial. Okay, right. So first we start with random variable. Now, random variable has two types. Two types. One is discrete random variable. The other one is continuous random variable. Discrete random variable, they are numbers. And these numbers, they are whole numbers. Whole numbers means 0, 1, 2, 3, 4, 5. There is no 1.5. There is no negative numbers, right? No negative numbers, no 1.5, no 2 and 1 quarter. No, they are whole numbers one by one, starting from 0. Now, when do we use whole numbers? When do we use whole numbers? If you remember in maybe standard 1, you learn number of cats, then they draw all the cats there. 1 cat, 2 cats, 3 cats, 4 cats. So they are actually number of things. Number of things. Okay? Number of people, number of cats, number of white cars, number of blue cars. They are numbers. So these numbers you cannot have half. You cannot have half. Either you have 1 car or 2 cars. Cannot have 1.5 cars. So these numbers, they are called discrete random variable. Discrete means one by one like that. Okay, so let me read here. Random variables that have countable numbers of values, usually taking values like 0 and positive integers. They are known as discrete random variable. So discrete random variable is represented by the letter capital X, capital X. So this capital X, they are number R, such that R equals to 0, 1, 2, 3, and so on. Okay, so they are numbers. The capital X represent a number, right? The number starts from 0, 1, 2, 3, 4, like that. Okay, discrete numbers, discrete random variables, they are whole numbers. Okay, any question regarding discrete random variable? No. No, then we go on to the second one. Okay, the second is continuous random variable. Okay, no question, good. Okay, no question. Now, what is a continuous random variable? Continuous random variables, they are not whole numbers. They are numbers within a certain range. That means from this number to this number. Now, let's say, example, I say the height of students in your class. Height of student in your class, maybe the shortest one is how many cm? Who is the shortest in your class? 140 cm. Okay, let's say 140 cm. Don't laugh. Shortest 135, is it? Maybe 135. Okay, 135. The tallest in your class is which one? Tallest in your class is maybe 180 cm. Anyone taller than 180 cm? No. So we say, oh, the height of the student in your class is a continuous random variable. Height of student in your class, and this continuous random variable is from 135 until 180. So it is between two numbers, but it can be, it's not necessarily 135, 136, 137. It can be decimals, it can be fractions in between these numbers. So it can be any real number between these two numbers, right? Now, other than height is a continuous random variable, the mass, your mass, how many kg? 40 kg? Yes. Maybe the lightest one, 40 kg. The heaviest one, maybe 70 kg. Okay, 70. So the your mass is a continuous random variable. It is from two numbers, 40 kg to 80 kg, something like that. So it is not whole number, it's a continuous range of number, right? So let me read this number two. Number two, random variables that are not integer but take the values that lie in an interval are known as continuous random variable. So continuous random variable, let's say we use the letter capital Y. Capital Y, okay, is the set of numbers y, small y, such that y is the pupil's height in centimeter, and it is between two numbers, between the smallest number and the biggest number. Just now we say 135 and 180 cm, right? So between two numbers, it can be anything. That's why it is a continuous range. It's a continuous range. Okay, now we are going to look at this exercise 5.2. So this exercise 5.2, there is a random variable there. Can you tell me what are the values or the range of values for this random variable? So if you can tell me the value, or you please tell me it is a continuous random variable or a continuous random variable. Okay. Who else want to read? Or Li Ying, you still read? You
Okay,
still read?
okay.
This one, exercise 5.2.
Write down all the possible outcome in set notation for each of the following events. Determine whether the event is a discrete random variable or a continuous random variable. A. 6 prefects are randomly selected from pupils of from 5. X represent the number of prefects who wear glasses. B. 7 patients are randomly selected from a hospital for blood tests. X represents the number of unprivileged patients. C. The shortest building in Saroja city is 3 meters, while the tallest is 460 meters. S represent the height of the building located in the city of Saroja.
Okay, right. Now what they want you to write down is in set form, right? Let me underline this. Write down the possible outcome in set notation. Set notation is this one. Set notation is like this. Okay. So you tell me x equals to, then the bracket, and you write down the numbers there, right? Six prefects are chosen at random, right? So from the six prefects, how many of them wear glasses? So the discrete random variable here are the people that wear glasses, but this group of people, they are prefects lah. So how many wear glasses? X represents the number of people wear glasses. What can this X be? Okay, number one, I ask you, X is a random or discrete variable. If it is random variable, can you tell me the numbers? If it is a discrete random variable, then tell me the numbers. If it is a continuous random variable, tell me the range between two numbers. Okay,
Discrete.
discrete. What are the numbers?
0, 1, 2, 3, 4, 5, 6.
Correct. 0, 1, 2, 3, 4, 5, 6, right? So, yes, it's a discrete random variable, 0. No need to write this RR also, never mind. Just write down 0, 1, 2, 3, 4, 5, 6, right? So X is a discrete random variable. Part B, X represent the number of underprivileged patients. How many of them altogether are selected?
Seven
Seven.
patient.
So seven patients. How many of them are underprivileged? Possibly lah. Possibly how many? Can it be
Zero one.
zero? Yes.
Yes.
Can it be one?
Yes.
Yes. Tell me the
Zero
numbers.
one. 0, 1, 2, 3, 4, 5, 6, 7.
Correct, right? So 0, 1, 2, 3, 4, 5, 6, 7, and this is a discrete random variable. Okay, part C. The shortest building in Saroja city, 3 meters. 3 meters is a single story house. And the tallest is 460 meters. Not very tall. Okay, X represents the height. So can you tell me this X is a discrete
Mm,
or a
continuous.
continuous? Correct, it is a
Continuous.
continuous random variable. So if it's a continuous random variable, it has to be between two values. What are the two
Yes.
values?
3 and then X and then 460.
Correct, very good. Okay, very good. So it's a continuous random variable, and let's say part C, huh? C y equals to this type of bracket between 3 3 less than or equal. Where's the less than or equal sign? Less than or equal. Yeah, if you use y, then you put y, right? Then less than or equal, how many? 460, 460, and put the bracket there, right? So it is like that. So y is between 460, right? Okay, so this is the answer, right? After that, we're going to look at tree diagram. You must know how to draw the tree diagram, right? Li Ying, you read question number 1.
In a mini hall, there are three switches to turn on three fans, as represent the number of switches that are turned on at a time. A. Write X in a set notation. B. Draw a tree diagram to show all the possible outcomes and find the probability for each of them. C. Determine the total probability distribution of X.
Okay, now of all these, A and B, you know what they are talking about. Probably C, I have to explain to you, right? Okay, now let's say we look at the first question. Write down X in a set notation. Okay, right. Now, the probability of turning on a fan is one third. One third. Okay. So the probability of the fan on, we call it H lah, is one third. Then the probability of the fan off is H prime. Now H prime is the complement of H. This one, have you learned this notation? H prime in your set or in your probability, the mathematics
Yes.
probability. H
Yes.
is one third, H prime is the complement. So it is 1 minus one third, which is equals to 2 third. Now there are three fans. Fan number 1, fan number 2, fan number 3. Some can be, it can be on, all the three on. It can be off, all the three also off. It can be one off, then two on, then two on, then one off, and so on. So there are many possibilities there, right? Okay, so actually the first fan can be on or off. It can be on or off. So there are two ways. The first fan, there are two ways, on or off. On, I say it is H. Off, I say it is H prime. Okay. So first one can be H or H prime, two ways. Second one can be H or H prime, also two ways. The third fan can be on or off, so also two ways. So each fan has two ways, on or off. So the total number of ways is 2 times 2 times 2. So actually there are altogether 8 possible outcomes. Well, if you want to list out all the 8 possible outcomes, you have to draw a tree diagram, right? So the number of light that is fan that is on is actually 0, no fan on, 1, only one of them is on, the other two off, then or x equals to 2, 2 fan on, right? One of them is off. Then the third one is x equals to 3, 3 of the fans are on. Okay, so if you look at on only, there will be only 0 fan on. That means none of the fan on. One fan is on, two fans on, or three fans on. That's why we have x equals to 0, 1, 2, 3. So the number of fan that is on is a discrete random variable. What is this x? X is the number of fan. Number of fan that is what? Number of fan that is turned on. So actually you can have 0 fan turned on, 1 fan turned on, 2 fans turned on, or 3 fans turned on. Okay, right? So now X represent the fan that turned on. Any questions so far?